Okay, good afternoon again. For our last topic, application of derivatives for this topic, yung mga before natin mga discussion, application naman siya and dapat medyo aware din tayo din sa mga formulas natin for the area. For example, yung mga area sa triangle and yung mga other na trigonometric function natin, dapat aware pa rin tayo. Kung hindi man, recall na lang din yung mga other natin na formulas and also yung mga formula natin for the derivative and also for the anti-differentiation kasi matatakad din natin siya today. Ayan. So for the objective, at the end of this session, you will be able to use derivative and differentiation to determine the rates of change and to get the largest value or the smallest value of a function. Okay. Then, yung first topic natin is the related rates. Okay, for the related rates, we have here yung first natin na problem, which is consider a sphere of radius 10 cm. If the radius change 0.1 cm, a very small amount, how much does the volume change? So, for this problem, dapat determine muna natin, ano ba yung formula natin for the volume? Kasi yun yung hinahanap natin, di ba? Sabi niya is yung how much does the volume change? And yung given natin dito is we have the sphere of radius, which is yung 10 cm and also the radius changes of 0.1 cm. So, ang pwede natin gamitin is the formula for the volume natin kapag meron tayong sphere. So, for the formula for the sphere, we have here yung B is equal to 4 over 3 pi r raised to 3. So, for the derivative, for this problem, ito yung derivative niya. Ang application lang naman natin dito is almost the power rule lang siya, which is para mag-derive, so V is equal to dV lang din siya, and yung formula natin for this, kaya naman na-cancel yung 3, is because yung sa itong 4 over 3 pi r raised to 3 is ginamitan lang natin ang derivative ng power rule. For the power rule, we have yung x. Diba? Kapag meron tayong given na x raised to n, so kapag dinerive natin to is equivalent lang siya by n x n minus 1. Diba? Ito lang yung formula natin, n minus 1 for the formula natin. So, kung ito yung gagamitin natin, na formula natin, pasensya na dun sa sa pagsusulat ko. Medyo hirap lang din ako magsulat kapag ganito. So, ayan. So, for the formula, for the derivative, if ang i-derive natin for the power, let's say we have the x raised to n, which is yung given natin n dito is yung 3. And yung parang assumption natin, yung x natin is yung r, or yung variable natin. So, kapag nag-derive tayo ng power rule, yung n natin is magiging parang whole number lang siya. And yung x natin, yung ito, as is lang din siya, raised to n minus 1, which is yung exponent natin is ma-minus natin sa 1. So kapag ganun yung nangyari, kapag dinerive natin to, so magkakaroon tayo dito ng value as, so kapag ganyan, di ba? Pag dinerive natin siya, magkakaroon tayo, yung n natin is 3. So magkakaroon tayo dito ng, let's say ito yung kanina natin, which is itong 3. So na-cancel na itong 3 kasi, kapag dinerive na siya, we have yung 4, diba? 4 times yung value natin ng 3, which is yung based din sa differentiation natin over nung 3 natin. Kaya dun sa derivative natin, na-cancel na rin itong 3 natin. So 3 over 3. Kaya yung naiwan na lang dito is yung 4. And for the pi, as is lang naman yung pi natin, and yung r natin is magiging raised to 2 na lang siya. Kasi na-derive na natin, sabi natin, based din sa formula natin, we have yung n natin as yung 3 and then mag-minus lang tayo ng 1. Kaya yung mismong exponent na lang natin na naiwan dito is 2. And then we have yung dr. And then after that, since we have naman yung given natin na radius, papalitan lang natin yung value ng radius and also yung radius changes, which is yung dr natin. So ito na yung magiging value natin. We have the dv is equal to 4 pi. And again, yung r natin, which is 10 centimeter squared, times the dr natin or the radius changes or the 0.1 centimeter. And multiply lang natin sila. Kaya tayo nagkaroon ng value na dv is equal to 4 pi centimeter raised to 3 or cubic centimeter natin. Or the volume would change by approximately 40 pi cubic centimeter. For our next problem, we have suppose that the radius is changing at an instantaneous rate of 0.1 centimeter per second. possibly if the sphere is a soap bubble or a balloon. So ito the example natin. So we have here as a soap bubble or a balloon. So for this problem, almost the same lang din siya with our first problem. So we have the formula as V is equal to 4 over 3 pi r raised to 3. So we have yung derivative again, which is dv over the dt, which is yung with change na to as yun sa time natin. Ayan, for with time na siya, kaya meron tayong dt dito. Is equal to dun sa derivative natin, which is 4 pi r squared dr over the dt. And then, same lang, papalit lang natin yung value natin. So we have the dv over dt is equal to 4 pi, and yung value natin for the r, which is 10 centimeters squared, times the dr over the dt, which is 0.1 centimeter per second. So given naman siya dito sa value natin na to, which is the instantaneous rate naman siya. And then for the value of dv over dt is equal to 4 pi centimeter cube over second, or the sphere is growing at a rate of 45 centimeter cube per second. And then, pag may question na, sabihin mo lang kung may question ka. You can still interrupt me while I'm discussing the subject. So next natin for the next problem. Water is draining from a cylindrical tank at 3 liters per second. How fast is the surface dropping? So for this naman, ang hinahanap natin is, ano yung hinahanap natin for the value natin? Ano yung hinahanap natin for the problem? So we have here yung mismong kung gano'n siya kabilis sa surface dropping natin, which is yung formula natin for this problem is we have the dv over the dt is equal to negative 3 over liter per second, or yung given natin is pinalitan lang siya ng value natin into cubic centimeter. So 1 liter is equal to 1,000 cubic centimeter lang siya. Kaya meron tayo ditong negative 3,000 cubic centimeter per second. And ito yung hinahanap natin, which is the dH over the dt, or we need a formula to relate with our V, which is the volume, and also yung height natin, which is ito yung given natin na cylindrical tank natin. And then again, application lang ng formula natin for the cylinder. The formula for the cylinder for volume is the V is equal to pi r squared each. And then where yung R natin is constant, kaya yung mismong formula natin, since constant naman siya, hindi na natin papakilaman yung mismong derivative ng R natin. Therefore, we have the dV over the dt is equal to pi r squared times dH over the dt. And substitute lang natin yung value natin. Again, we have the value for the dV over the dt, which is negative 3,000 cubic centimeter over second. And then yung right-hand side natin, which is the pi r squared dH over the dt. And then, para makuha lang natin yung dH over the dt, halos parang cross multiplication lang din yung gagamitin natin dito. Kaya meron tayong value na negative 3,000 cubic centimeter per second over pi r squared. Okay, yung next naman natin is we have the steps for related rates problem. Yung first natin is to draw a picture, or we need to sketch. And then yung next natin na gagawin is we need to write down information. And then for the third step is write down what you are looking for. Then number 4 is to write an equation to relate the variables. So syempre dapat dito, alam natin yung mga formula na gagamitin natin. And then differentiate both sides with respect to t, or yung time natin. And then last is to evaluate. For our first problem daw, we have here yung hot air balloon problem. So hot air balloon problem, ito yung mismong problem na given natin. So sa given natin, we have yung theta natin, which is equivalent to pi over 4. And we also have yung d theta over dt is equal to 0.14 radius per minute natin. And the question is, how fast is the balloon rising? So ang hinahanap natin dito is the dH over the dt. So ibig sabihin, yung height natin with respect sa time. So for the height with respect sa time, we can use yung formula natin as yung sa equivalent natin ng tangent. Again, what is the formula for the tangent? Recall lang with our trigonometry na subject. Di ba, we have before yung SOHCAHTOA. Familiar ba sa SOHCAHTOA? For this problem, pwede natin gamitin daw yung tangent. Pero recall lang natin, again, ano yung formula natin for the tangent? paano tayo pwede makakuha ng value ng tangent?
Sine over cosine.
Okay. Or kapag ganito yung application natin, let's say, di ba, before sa triangle, di ba, we have the hypotenuse, which is itong part na to, and then itong part na to is the opposite, and also, we have here yung adjacent natin. So, kung sine over cosine siya, paano natin mapapakita dito sa triangle yun? Let's say yung sine, ano ba ang formula natin before? Parang mag-recall lang tayo. Ano yung formula natin for sine? Or, di ba meron na tayong formula na sa katawa? Pag yung sine yung hinahanap natin, we have the opposite, which is itong side na to. Opposite over the hypotenuse natin. Itong side na to, hypotenuse. And we have the cosine naman, which is the adjacent, which is itong part na to, over the hypotenuse. And for the tangent or the sine over cosine, we can use the opposite over the adjacent, yung opposite natin over the adjacent, itong part na to. So, therefore, we have yung formula for the tangent theta. Tangent theta as yung height natin, itong h or the opposite natin, and then the adjacent, which is the 500 feet natin. So, ito yung formula natin. And then, next natin gagawin is we need to derive based dito sa formula natin na tangent theta is equal to height over the 500 feet. So, for the derivation naman, syempre, kailangan natin malaman ano naman ang equivalent ni tangent natin kapag dinerive natin siya. So, ang equivalent ni tangent natin or tangent theta is equivalent siya by secant squared theta d theta over dt. And then for this naman, sa formula natin na to, kaya lang naman tayo nagkaroon dito ng 1 is because yung formula natin dito is pwede natin gamitin yung quotient rule or since we have yung constant value dito, 1 over 500 lang siya pag dinerive siya. Or we have the 1 over 500 dh over the dt. And same lang with our problem. Since given na naman natin again yung theta natin, given na rin yung d theta over dt or the theta with respect to time, and also yung 1 over 500 natin na to. So, palitan lang natin yung mga value na given natin. So, for the secant squared theta, pwede natin gawin na secant pi over 4 na siya since ito yung theta na given natin, and then squared lang natin. And then for the d theta over the dt, given na naman yung 0.14 and also the value of 1 over 500. So, as is naman siya. And solve lang natin siya. And for the computation, ito na siya. So, for the value, kapag nag-solve tayo, is since ito na yung computation natin or equivalent lang yung secant natin, pi over 4 into square root of 2, yun na yung ginamit natin na value dito. So, dito lang pinakita yung computation natin. So, kaya nakuha lang din naman yung value niya is gamit lang din ng Pythagorean theorem natin, which is given na naman din yung 1 natin, which is yung height natin. Again, itong 1 na to is itong value din naman. So, after nun, we have the square root of 2 squared times the 0.14 times the 500 para makuha natin yung dh over the dt natin. Or we have the value of 140 feet per minute. So, for this problem naman, we have a track A travels is for 40 miles per hour, and track B travels north at 30 miles per hour. How fast is the distance between the tracks changing 6 minutes later? So, for this problem naman natin is meron tayo ditong given na triangle. So, parang triangle siya, which is yung meron tayo dito yung letter B, which is nagta-travel siya north, and yung A natin is nagta-travel siya into east natin. And for the formula for the distance, yung distance na hinahanap natin is we have here, since ang given naman natin is meron tayong mile per hour, so yung for the distance niya, we have yung formula as yung rate times yung time natin. Okay, for this problem, ang given natin na rate for the A is the 40 mile per hour, and the given for the B natin is we have the 30 mile per hour. Okay. And also may given din tayo na y is equal to 3, given na x is equal to 4, and also z is equal to 5, which is yung mga distance natin. And then palitan lang natin yung value natin, which is given na rin natin yung 60 minutes. So converted na to into hour yung value natin. Kaya for the letter A, we have 40 times 1 over 10 is equal to 4. And Also, for this naman, yung 13 natin times 1/10 is equal to 3. Kaya nakuha yung mga distance natin na to. Yung 3 at saka yung 4 natin. And application lang din para nakuha natin yung mismong hypotenuse, which is yung 5 natin. Itong 5 na to is based lang din siya dun sa formula natin with the Pythagorean theorem. Nare-recall pa ba yung Pythagorean theorem na formula natin? Which is yung formula natin before for the Pythagorean theorem is we have the a squared plus b squared is equal to c squared. So parang ang meron dito is ito yung a squared natin, ito yung b squared, and also ito yung c squared. Pero dito, pinalitan lang natin yung mismong variable natin, which is yung a natin ay naging parang yung y na naging y siya. And then for the 4 naman, ito is naging x natin. Or we can say na we have the y squared plus x squared, or we can use the x squared plus y squared equals dun sa z squared natin. So for this problem, since nakuha naman na natin yung value ni y at saka ni x, so squared lang natin sila, then equal lang sa z squared. Since yung z natin is hindi pa siya given, gamitin na natin yung Pythagorean theorem. And para makuha natin yung z, which is yung itong value ng z, square root lang natin both side para makancel yung value ng ito. So we have here yung square root, and then also for this square root, para makancel lang natin yung squared natin. And therefore, the value for the z or the hypotenuse is equal to 5, or yung distance natin from this B and A. Yeah. Any question or clarification?
Wala po.
Okay, sige, clear naman yan ha. So yung medyo marami tayong nire-recall ngayon na formula ha. Ayan. And then on continuation naman natin for this problem, since hindi pa naman natin siya na-derive, so we will apply again yung pag-derive natin for this formula. For the x squared, y squared, and also the z squared, same lang siya ng application ulit ng power rule. So we have here, pag dinerive natin si x squared, we have 2x dx over dt. And then for the y squared naman, we have 2y dy over dt. And for the z squared naman natin, kapag dinerive natin siya, we have the value of 2z dz over the dt. And since all naman ng value nila is with 2, canceled na lang din siya. And papalitan lang natin yung value natin. So we have the value of y as 3 again. So as before na to, given na to. Yung x natin again, we have the value of x as 4. And then yung z natin as 5. And also yung kanina natin kinompute, which is the dy over the dt, which is given as 30. And also yung dx natin over dt, which is 40. So papalitan lang natin again yung value. We have 4 times 40 plus 3 times 30 is equal to 5. Since dz over dt is wala pa siyang value, yun yung i-compute natin for this problem. So, ayun. So, we have the 250 is equal to 5 times dz over the dt. The value for the dz over the dt is equal to 50 or 50 miles per hour. Ayan. So, for our next topic, ayan. So, a classic problem naman tayo, which is we have the rectangle naman siya, di ba? Kung mapapansin natin sa drawing. So, you have 40 feet of fence to enclose a rectangular garden along the side of a barn. What is the maximum area that you can enclose? So, we have here for the value of 40 minus 2x, which is yung mismong length natin. And yung width naman natin is considered as yung value natin ng x natin, which is given na rin based dito sa problem natin. And again, recall lang again, what is the formula for the area of the rectangle? Kasi yun yung hinahanap natin dito is the maximum area that you can enclose naman daw. Itong area na to. So, nare-recall pa ba formula for the area of the rectangle?
Width times length, ma'am.
Okay, ayan. So, ayan yung ginamit natin, which is the width times length. And we have here yung area, which is yung given natin dito, we can say yung length times width or width times length, same lang naman siya. For this problem, we have yung width natin, which is yung x natin, and yung length natin, 40 minus 2x. And then derivation, hindi pa pala siya, hindi pa derivation. So, minultiply lang natin yung x natin for the value, again. So, we have the 40x minus 2x squared. And then, after nun, dinivide yung value natin. So in order for us to have the A is equal to 40 minus 2x. Simplification lang nung value natin. And yung derivative natin for this problem. Which is yung itong value natin na to is derivation lang. So paano ba tayo magde-derive? For the derivation of this, we have the 40. And then kung mapapansin mo naman dito, power rule pa rin to, application pa rin ng power rule. Kaya tayo nagkaroon ng value ng 4. And yung x natin is naging x na lang siya, hindi na siya x squared. Which is again, yung formula natin is x raised to n. Ang equivalent nun is nx raised to n minus 1. Kaya nakuha natin yung 4x lang siya, which is yung sa derivation natin. And for this naman is 40. And to get the value of x natin, so transpose lang natin sa other side yung 40 natin and divide both side by 4. Therefore, the value of x is equal to 10, which is there must be a local maximum here since the endpoints are minimum. And since nakuha na natin yung value natin for the x natin, pwede natin palitan yung value natin to get the value of width and length. Since yung x natin is also equivalent with the width, so the width is the value for the width is 10 feet. And for the length naman, we can change the value of x lang here. So 40 minus 2 times yung x. So we have the value of length as 20 feet. Okay, next natin to continuation lang naman to din sa problem natin. Since we have na yung value for the width and also for the length, dito is continuation na para makuha natin yung value ni area. So 10 times 20 lang, the value of area is 200 feet squared. So the answer here is itong value na to. And then next natin is to find the maximum or minimum value of a function. Yung first natin na way is to write it in terms of one variable. Then second is to find the derivative and set it equal to 0. And then yung last natin na gagawin is we need to check the endpoints if necessary. Okay, for this problem, we have the example number 1. The problem is what dimensions for a 1 liter cylindrical will use the least amount of material. So we can minimize the material by minimizing the area. So for this naman, we need to consider yung formula for the cylinder, which is yung area ng cylinder, area for the cylinder. So again, for the formula for the area for cylinder, we have the 2 pi r squared plus 2 pi r h, where yung 2 pi r squared natin is the area of ends, and for the lateral area natin is the 2 pi r h. And given na naman siya dito. And again, so for the value naman ng height natin, since dito naman sa given natin na height, which is we have the value of 1 liter is equal to 1,000 cubic centimeter, we can use it with our formula as we have yung 1,000 is equal to pi r squared h, or the value for the h or equivalent ng value for the h is 1,000 over the pi r squared. Kaya dito meron tayong 1,000 over the pi r squared. And since pwede nating i-cancel si pi r, ayan, so cancel tayo, may titira na lang dito sa denominator natin is si r, since we only have here yung 1r and dito naman is we have 2 kasi naka-raise to 2 siya. Therefore, the formula we have area is equal to 2 pi r squared plus 2,000 over the r. And after nyan, derive again natin. For the derivation, we have a is equal to 4 pi r minus 2,000 over r squared. Or ito is application ng power rule, and for this problem naman is application naman siya ng quotient rule. And then for the continuation lang ng problem natin, which is, di ba, ang last natin is we already derive the formula, which is the formula is 4 pi r minus 2,000 over the r squared. And then equal lang natin siya by 0. And then the continuation, we have the 2,000 r equals sa 4 pi r. Or transpose lang natin into other side yung 4 pi r natin. And then in order for us to get yung value ng r, so simplify lang natin yung problem natin, which is we have na yung 2,000 is equal to 4 pi r raised to 3 natin. which is we have kasi dito yung R3 and also yung R natin. And then the value for the R is equal to cube root of 500 over pi, or equivalent lang siya by R is equal to 5.42 centimeter. And balikan lang natin yung formula natin kanina, which is yung formula natin kanina sa height is we have the 1,000 over pi R squared. So since nakuha na natin yung value ni R, which is 5.42 centimeter, we can get the value of H, which is yung height natin. So we have the value of H as 10.83 centimeter. One variable, use substitution to rewrite the function. And then for the second, if you are not sure that the extreme you found is a maximum or a minimum, you have to check. And then for the last, or for our number 3, if the endpoints would be the maximum or minimum, you have to check. So for this problem naman, we have the example number 2, which is we need to enclose a field with a fence. We have 500 feet of fencing material and a building is on one side of the field, and so won't need any fencing. Determine the dimensions of the field that will enclose the largest area. So for this problem naman, or for this solution, first is, in this problem, we have two functions now. The first function that we are actually trying to optimize, and the second is will be the constraint. So first again, daw is the for the optimization and for the constraints. And the next daw na need natin gawin is sketching the situation will often help us to arrive at this equation. So for the sketch naman, we have yung building daw, which is itong building natin, and we have the x value of yung x natin na gagamitin and also the y. And then yung next natin for the solution is we need to maximize the area of a field. We'll use 500 feet of the fencing. Yung 500 feet is given na kanina sa problem natin. And next natin, optimize the area. The amount of fencing is the constraint. So yun yung, and balikan lang natin, sabi natin, ang need natin dito is the optimization and also the constraint. And then for the solution natin, we have two equations for this. So yung first natin is the area. Since rectangle yung mismong sketch natin, kasi di pa sabi natin, we need to sketch yung problem. So the area is equal to x and y. So ito yung nasa sketch natin, which is we have the x and y. And then yung constraint natin, which is given yung 500 natin. And for the x and y, 500 is equal to x plus 2y. And solve natin yung constraints. To solve the constraints, we have x is equal to 500 minus 2y. And next is substituting this into the area functions gives the function of y. So we have yung function of y as 500 minus 2y times yung y natin na value. Kasi ito yung value natin for the x. Kasi yung area again natin, balik tayo din sa formula. The value or the formula for the area is x times the y. Kaya tayo nagkaroon dito ng 500 minus 2y times yung y natin. Or equivalent siya as 500y minus 2y squared. And then find the largest value of on the interval of 0 to 250, which is yung 0 is the x, and also here is the 250 is for the y natin. Note that the interval corresponds to taking y is equal to 0 and y is equal to 250. The two sides and no width. Also, if there are two sides, each must be 250 feet to use the whole 500 feet. So kaya yung kaya tayo nagkaroon ng 250 feet. And then for the next naman, for the continuation lang natin, recall that the maximum value of the continuous function, which we got here on a closed interval, which we also have here, will occur at the critical points and or endpoints. So based dun sa problem natin, kunin lang natin yung mismong derivative natin, and para makuha din natin or to find yung value natin for the critical points natin. Again, recall lang natin yung formula natin for the area of y. So balikan lang natin. For the area of y, we have the 500 minus 2y times y, which is 500y minus 2y squared. So for this, i-derive lang natin which is itong value na to is as is lang siya. Pag first derivative is magiging 500 na lang siya. And for this, using the power rule again, we have the 4y na lang siya. Kasi again, yung formula natin for the power rule, so 2 times yung exponent natin, which is 2 again, and then y times raised to 2 minus 1 natin. Kaya nagkaroon tayo ng 4y. Therefore, the first derivative is we have the a prime or the first derivative of y is equal to 500 minus 4y. Any question ba? Baka masyadong nabibilisan sa discussion.
Hindi naman, wala naman po, ma'am.
Okay, sige. Okay naman, okay pa. Baka kasi medyo nabibilisan na sa discussion natin. Okay. So again, ayan. Sabihin natin, kunin natin yung derivatives. So nakuha natin yung first derivative natin. And we need to know the critical points naman siya. So setting this equal to 0 and solving gives a lone critical point of y is equal to 125 naman siya. Yung value natin for the y. And plugging this into the area gives an area of 31,250. So pinalitan lang natin naman yung value dito ng y natin to get yung value natin nitong 31,250 cubic feet. And then according to the method of absolute extrema section, this must be the largest possible area since the area at either endpoint is 0. And then next natin is to get the x by plugging in our y into the constraint. So kapag gano'n naman, yung value naman natin, yung x naman yung papalitan natin, balik lang tayo din sa formula natin. Again, the formula for x before, dun sa binigyan natin formula is we have the 500 minus 2y. Kaya tayo nag-earn dito ng 500 minus 2 times yung given natin na y, which is itong y na to, is 125. Therefore, we have the value of 250 natin. 250x. And then the dimensions of the field that will give the largest area, subject to the fact that we use the exactly 500 feet of fencing material or 250 times yung 125 natin based dun sa problem natin, which is given natin yung x natin is 250 and for the y natin is 125. Any question pala dito before we proceed with our next problem?
None po, ma'am.
Okay po. Okay, for the next problem naman natin, which is the problem number 3. So for the problem number 3 daw, construct a box whose base length is 3 times the base width. The material used to build the top and bottom cost $10,000 per cubic square feet, and the material used to build the sides cost $6,000 square feet. If the box must have a volume of 550 cubic feet, determine the dimensions that will minimize the cost to build the box. And so we have the given na naman dito, which is yung first natin is yung length. Yung length daw ay 3 times na volume ng base width natin. So kaya tayo nagkaroon dito na since kailangan natin, di ba, based sa problem is kailangan natin siyang i-illustrate or i-draw. So given as yung length natin is equal to 3W, yung W natin is the width. And then we have na yung dito is the height also. So given natin na box and also yung side ng width natin. And then next natin is minimize the cost of the materials subject to the constraint that the volume must be 50 cubic feet natin since dito yung given natin, which is itong volume natin as 50 cubic feet. And then next natin it is note as well as that the cost for each side is just the area of that side times the appropriate cost. Ito na yung paggagawa ng equation natin, which is the two functions will be working with here this time, or we have the first is to minimize, and also next natin is the constraints yung gagamitin natin na constraints natin. So based ito sa problem natin, we use the variable c for the problem. So we have yung 10 natin, 10 times yung 2LW natin, and then plus yung 6 times yung 2WH natin, or the width times height plus yung 2L times height natin. which is yung given natin dito sa value natin, is first is the top and the bottom post, the 10,000 feet, which is yung ito, given natin yung top natin, either ito or ito. So, kaya tayo meron tayong 2L times yung length times yung width natin. And then next naman natin is yung 6 natin, which is build at the side cost natin. So we have two sides. So we have the 2WH and also the 2 length H. And then simplify lang natin, we have the 60W raised to 2 plus 48WH based lang dito sa given natin. And for the constraints natin, since ang constraints natin, the formula for this is the length times width times height natin, na equivalent lang siya by 50, which is yung volume natin again. Then simplify lang natin, we have the 3W squared H, which is yung base lang din dito sa given natin. Yung length natin, di ba, ang value for the length is 3W. Kaya pinalitan na natin dito yung value natin ng length. Kaya tayo nagkaroon ng W squared, 3W squared. And then assist lang yung H natin. And the next for our solution, we need to solve the constraint for one of the variables and plug this into the cost. It will definitely be easier to solve the constraints for each. Again, based on the formula natin na length times width times height, we can consider yung formula na yun to get the value of each. So for the formula for each is we have, or the height, we have the 50 over the 3W squared. And then plugging this into the cost gives us itong equation na to, which is we have the CW is equal to 60W squared plus 48W. And yung mismong value ni H, which is 50 over 3W squared. And then after na, simplify lang natin again. So we have here for the CW is equal to 60W squared plus 800 over W natin. And then kunin lang natin si first derivative and second derivative. Again, yung first derivative natin is magbe-base tayo dito sa equation natin, which is the 60W squared plus 800 over W natin. And then for the second derivative natin, magbe-base naman tayo sa first derivative natin, which is ito naman yung ita-derive natin. For the first derivative or the CW, which is ito, C prime W, we have 120W based lang to dun sa value natin ng ito, which is 60W squared. And itong value natin, which is the 800W raised to negative 2, based lang to dun sa quotient rule, so derivative lang nito. Therefore, we have the value for the first derivative as 120W raised to 3 minus 800 over W squared. And then, based dito, kukunin lang natin yung second derivative, which is ito yung second derivative natin is equal to 120 plus 1,600 W raised to negative 3. And then, for the critical points naman daw, we have yung first critical points natin as yung 0. And next naman natin is yung critical point will come from determining where the numerator is 0. So kasi di ba ang rule naman natin for the critical point para ma-determine natin is either yung value natin is equivalent sa 0 or yung value natin is magiging undefined siya. So for this problem, yun na nga. So una is we have yung value na to and then we have yung value na itong sa baba natin, which is the 120 W raised to 3 minus 800 is equal to 0, or we have the cube root of 800 over 120, or equivalent lang siya by 1.8821. By using the second derivative, whatever the value of W that we get, it will have to be positive, and we can see second derivative that provided the W is greater than 0. We will have the second derivative as W is equal to 0, and so in the interval of the possible optimal values, the cost function will always be concave up. And so itong mga concave up na to, ito na yung mga sa previous lessons natin. And so yung value natin for the W is 1.8821. So as discussed here, must be an absolute minimum cost. And then for the remaining dimensions naman natin, since ang na-compute pa lang natin is the W, we can still compute for the value of L, which is the length, and also for the value of H. Again, the formula for the length is 3W. So substitute na natin yung value ng W, which is 1.881 times the 3. So we have the value of length as 5.6463. And then again, the formula for height naman, we have the 50 over 3 W squared. Again, substitute lang natin yung value ng W. So the formula, again, ito. Then the value for the H is 4.7050. Or also, even though it was not asked for, the minimum cost is 637.80. So additional na lang naman to. So ano lang siya, hindi naman siya needed sa problem, pero in-include lang siya. Any question or clarification regarding this problem?
Wala naman po.
Okay. Anti-derivative. So bago tayo mag-anti-derivative, nare-recall ko ba again kung ano yung anti-derivative? Or nakalimutan na kung paano mag-anti-derivative? Kung medyo nakalimutan, recall lang din natin again yung pag anti-derivative. So parang anti-derivative, so kabaliktarin lang siya ng derivation natin, or parang ano siya, parang integration na siya. Kasi 'di ba, si derivative or differential calculus is kabaliktaran niya si integral calculus. So parang ganun lang din ito for the anti-derivation or derivative natin. Wait lang, nakapag-take na ba kayo ng ano? Wala pa nga pala, differential calculus pa nga lang pala kayo. Pero natakil naman to, di ba? So for the antiderivative of function of f of x is an antiderivative of a function of f of x if f prime x is equal to f of x for all x in the domain of x. So the process of finding an antiderivative is anti-differentiation. Yun na nga, kabaliktaran lang siya ng derivation natin or the anti-differentiation. Okay, for the first problem. For the first problem naman natin is we have here find the velocity and position equation for a downtime acceleration of 9.8 meter per second squared and an initial velocity of 1 meter per second downward. So for the solution, again, recall lang natin yung value natin, which is given na naman yung acceleration natin, which is yung a of t with respect to time natin, which is yung 9.8, or the gravitational acceleration natin na 9.8 meter per second squared. So we let the down be positive. And then since the acceleration is the derivative of velocity, velocity must be the antiderivative of acceleration. Again, for this problem naman, yung formula naman natin na gagamitin is the velocity naman with respect din sa gravity natin. For the formula, we have yung v of t is equal to 9.8t plus yung c natin. So, ito is the formula for the, or yung acceleration natin is ito. And then the time, or the gravity times yung time, or the acceleration natin with respect to gravity, plus the value of c. And then for the derivative, we have here yung v of t is equal to 1, and then equal siya sa 9.8, and yung t natin is equivalent lang siya by 0, kaya tayo nagkaroon dito ng 0. And for the value, 1 is equal to c. Yan siya. So v of t is equal to 9.8t plus 1. And then for the continuation lang natin, for the formula natin, ito. So s of t is equal to 9.8 over 2 t squared plus t plus c. So base lang din naman siya dito. So antiderivative lang naman siya. Kaya tayo nagkaroon ng t squared over ng t. So kasi ang before, di ba, pag nag-derive tayo ng formula for the power rule, we have yung kaninang formula natin, which is yung, we have the n times x raised to n plus n minus 1. So for this naman na formula natin is, yung integration naman yung gagamitin natin. Kaya tayo nagkaroon ng over 2 dito, and then yung 2 natin. And then for the anti-differentiation naman, or antiderivative natin for the 1 is equivalent lang siya for the value of t, or the reverse. And the power rule is in reverse. Kaya siya nagkaroon ng gantong value. Increase the exponent by 1 and multiplied by the reciprocal of the new exponent. Ayun na nga siya. Parang application lang din kasi ito ng integral calculus natin, or the anti-differentiation. Kasi kabaliktaran nga siya ng derivative natin. Since velocity is the derivative of position, position must be the antiderivative of velocity. May question ba kung paano to nakuha? Itong value natin na to? May question ba? Or nagets ba kung paano siya kinuha?
Naguluhan ko yung konti.
Ayan. So, balikan lang natin ha. Yung for the, sulat lang ako para madali. Again, for the x and natin, di ba for the derivation natin muna. Ano ulit ang derivation natin if we have the power rule? Yung kaya natin diniscuss. Let's say we have the x raised to n. What is the derivation for the x raised to n kanina? Diniscuss natin to, di ba, na for the derivation, we have yung n natin, n times yung x natin, raised to n minus 1, di ba? Na-recall pa to, yung kanina natin diniscuss.
Yes po.
Okay. For that problem, ganyan yung gagawin natin. Pero, if we need to use yung the anti-differentiation or the application of the integral, then halos integral kasi itong power rule na to. So, yung value naman natin for this naman, if meron tayo agad na power rule, iba na yung formula niya. So, we have yung x raised to n plus na siya. Plus 1 over, naintindihan ba yung sulat ko?
Opo.
n plus natin ang 1. Okay. So, kung ginamit natin for this problem, for itong problem na to, ito kasi yung ginamitan natin ng ng anti-differentiation. Kung ang ginamit natin na formula is ito, kung meron tayong derivative, ang magiging value na lang natin dito is 9.8 kasi mawawala na yung t kasi nga dito base yung x natin, siya yung t. So, if we have the 1 minus 1, so magiging 0 na to. Kaya kung ang derivative ang gagawin natin, magiging 9.8 na siya. Pero, since ang ginagamit natin is the anti-differentiation, itong formula na to, yung ginamit natin para dito sa problem na to. Ayan. So again, kung ito yung formula na ginamit natin, based dito sa problem natin na to. So as is, we have the 9.8. And then, assume natin na yung t natin is the value of x here sa problem natin. And since we have yung t lang, t is equivalent lang siya, di ba? Meron tayong, kapag meron lang tayong variable, equivalent nito, meron tayong 1 lang na exponent. Tama ba?
Opo.
1 na exponent. So, if we have yung value natin na exponent as 1, sabi natin dito sa formula, we have the x raised to n plus 1. So, if we have yung n natin as 1 and yung x natin as t, so 1 plus 1 is equivalent to t squared. Kaya tayo nagkaroon dito ng t squared. And then for the denominator, based sa formula natin, we have yung n. Again, n is 1 plus yung 1 natin. Kaya tayo nagkaroon dito ng 1 plus 1. Kaya tayo nagkaroon ng value of 2. Yan. Okay? Nagets?
Yes,
Okay. So, ito naman, question naman, bakit tayo nagkaroon dito ng t? Again, for the derivation, kapag nag-derive tayo ng constant value, which is yung 1, sana ba yung, sana yung pangsulat ko? Ayun, nawala. So, kapag derivation ang ginamit natin, any constant value, let's say yung constant value natin is equivalent dito. Pag derivation ang ginamit natin, equivalent lang to sa 0, di ba, kapag nag-derive tayo. Kapag derivation ang in-apply natin dito, equivalent lang to sa 0. Since anti-differentiation yung ginagamit natin, so itong value natin na to is magkakaroon tayo ng c times yung x natin. Kapag equivalent siya dun sa value ng c natin. Let's say yung c natin is 1. So yung 1 na to is magkakaroon tayo ng times yung x natin. Sabi natin yung x natin is assumption natin is t. So equivalent nito is meron tayong 1t or equivalent lang siya by t. Kaya tayo nagkaroon dito ng t. And ito is additional na lang to for the formula is plus c or the constant value. Plus c na siya talaga. Any question or naintindihan na kung paano nakuha natin itong 9.8 over 2 times the t squared plus t plus c?
Opo,
Okay na?
naintindihan na.
Okay.
Opo.
Let's proceed with our next slide. Ayan. For our next slide na, okay, for same problem pa rin naman. Given si acceleration as 9.8 meter per second squared and also the initial velocity of 1 meter per second downward. Ayan, given na naman siya dito. And, ayan, so yung mga given natin na formula, which is yung acceleration of time is 9.8. The v of t is 9.8 plus 1. And also yung formula natin for the s of t is equal to 9.8 over 2 t squared plus t plus c. Or equivalent lang siya as na-simplified natin as 4.9 or ito yung naka-divide by 2 na t squared plus t plus c. And then for the initial position is 0 at time 0. So palitan lang natin yung value natin yung time kasi nga sabi natin is 0 lang siya. So we have here as 0 is equal to 4.9 times 0 again, or the 0 squared plus c 0 plus yung c natin. Or equivalent lang siya by 0 is equal to c. Or we have yung formula natin as s of t is equal to 4.9 t squared plus t, which is ito lang siya. Ito ang formula na to.